and welcome to Kane Maths. In today's video we're going to be showing you how to use Algebra Tiles, a great tool for solving simple linear equations. You can see they are represented 2x plus 1 equals x plus 5, and I want to solve that equation so I get x only on one side. So notice I've got x on both sides, so I'm going to start by removing x from the right, and then I'm going to do the same on the left. X plus 1, do the same with plus 1, and then plus 1, and you can see there that I have x equals 4. And that's what we call solving. And I could check 2 times 4 plus 1 is 9, and 4 plus 5 is also 9. Of course, some people think they don't like algebra.
Oh, algebra's awful.
Exactly. But actually, algebra should be your friend because it unlocks so many interesting questions later on in mathematics. Or maybe you look at this and you say, well, I can do that, I can guess it. Who needs techniques? It's clearly going to be 5, isn't it? Or you say, well, that's going to be 4 times 2. I can guess that one. It's not exactly very difficult, is it? What about this one? A little bit harder. Well, maybe at school you learned the reverse operations method. You say, well, I take away 1 and then I divide by 3 and it looks something like this. Well, that's great in as far as it goes, but once we get on to the more challenging algebra, actually the reverse operations method lets us down. So, for example, 3x plus 1 equals x plus 5. What are you going to take away? Plus 1 or the 5? And you've got x on both sides. That's really quite tricky. What about this one where I have a negative x and a negative 3? What's going to happen there? Well, it's worth learning to manipulate algebra and to use our algebra tiles to help us with that. So what does it all come down to? Well, we want to get x by itself on one side of the equation. There's one simple rule. Whatever I do to one side of the equation, I do the same on the other side. And let's just pause and demonstrate that outside. Balancing equations is like balancing some weights on a stick. Here, I have 2x's equals x plus 6. I can add an x to both sides and they stay in balance. Or I could take 2x's from both sides. If I added 3x to one side, it would all go wrong. Whoa! I think we need to rewind that one. Now with my students, I normally give them some cut-out pieces of card with these algebra tiles already prepared, and they can move them around their desks. I want to encourage you to do the same thing for this video and make yourself some x's and negative x's and positive ones and negative ones. So let's demonstrate how we do this. X plus 3 equals 5. Well, first of all, let's have an x, then we'll have a 3, and then on the right hand side we'll have plus 5. So bring them all out there one at a time. So remember, whatever I do to the left hand side, I must do to the right hand side. So I can take away a 1 on the left and do the same on the right. I can do another one. I'm getting closer to having only x by itself. Let's try the last one. And there you can see, actually, I have x equals 2. Now I can check that. 2 plus 3 is indeed 5. It's not very complicated, but we're starting really simple. Here's another example. 2x equals 8. I've already put the tiles up here for you. So I might want to, you might say, well, I can guess that was going to be 4, isn't it? So you might say, well, I'll take away x from one side and 4 from the other side. But actually, that breaks the rule. It has to be whatever I do to one side, do the same to the other side. So what am I going to do? Well, I'm going to divide. And division is just grouping. So let's take my tiles, let's rearrange them. Let's have an x up there. And imagine I had, let's say, 8 cakes, and I wanted to share these cakes between 2 people. And suppose I said, well, you can have a couple there, and you can have a couple, and we'll give you 3, and we'll give you, there's 4, and there's, tell you what, let's make it 5 and 3. That wouldn't be fair, would it? People would object about that. To share evenly, it has to be 4 and 4. Well, that's what we call division. And so with my algebra tiles, I will draw basically an oval so that the ovals are the same, and essentially I'm dividing by 2. I'm saying x equals 4. I'm not solving it. You can check that one, that 2 times 4 does indeed give me 8. So again, very, very simple, but it develops as we go on. What about 2x plus 1 equals 7? Well, going to do exactly the same thing. Let's get rid of the 1 from one side, get rid of 1 from the other side. I've got 2 lots of x. Let's break it into 2 groups. So move that x up, and let's begin to share out those 1s. And then just as before, we're going to draw our ovals. And you can see that x equals 3, x equals 3. Now we can check that one. 2 times 3 plus 1 is indeed 7. What I want you to do right now is hit the pause button and try some of these. Do use the algebra tiles, set up 4x's, set up positive 8, manipulate them, and I'll give you the answers in a moment. So there are your answers. X is 2, x is 5, x is 1, x is 6, and x is 3. How did you get on? If you're not sure, go back and have another try. That's the wonder of YouTube. Well, let's try some more complicated ones. So here we have 3x equals x plus 6. Previously, we had 1s on each side. This time, do you notice we have an x on both sides? Exactly the same concept. So I'm going to start by taking away an x from one side, and then I'm going to do the same to the other side. So I have 2x equals 6, and again, just as before, we're going to group it into 2 equal groups. And now I'm going to draw my ovals, so you can see that. And you can see that x equals 3. And again, we can check that. 3 times 3 is 9. 3 plus 6 is 9. So let's make it a bit more challenging. 2x plus 1 equals x plus 5. We've got constant terms and variables on both sides. What do? Well, take away an x and take away an x, just as before. Take away a positive 1. Take away a positive 1. They're both there. And can you see what's happened? We have x equals 4. 2 times 4 plus 1 is 9. 4 plus 5 is also 9. Algebra Tiles allows us to do this simple manipulation. 2x plus 5 equals x plus 1. Why don't you pause and have a go? I have 2 x's, I have 3 x's. Let's start by getting rid of some of those x's. Take 1 away. I've still got another x, take that one away. Take 1 from the other side. I'm stuck with x plus 1 equals 5. Take away the 1. Take away another 1. What am I left with? X equals 4. Now, it's on the right-hand side. Does that matter? 4 equals x is the same as x equals 4. It doesn't matter which way around. The challenge is to get x by itself on one side of the equal sign. So, as about this one, this one is a little bit trickier. So here, first of all, I'm going to start by removing an x. But look what happens next when I get rid of the positive ones. So I'm going to just take away positive 2 from the right and positive 2 from the left. So I have 3x equals 0. How do I make sense of that? Well, let's do the same thing. Let's get our ovals. We're going to group them. There's my first group, and my second group, and my third group. So what do I have in each group? I have x equals 0. X equals 0, x equals 0. Odd, isn't it? And yet, 4 times 0 plus 2 is 2, and 0 plus 2 is 2. So again, please pause, try these yourselves. A little bit harder, I appreciate, but have a go and keep practicing. And I'll give you the answers in a moment. And there are now your answers. X equals 2, x equals 3, x equals 3, x equals 5, and x equals -2. So, talking about negatives, what are we going to do with this one? X minus 1 is 5. We haven't had negatives before, so let's have a look at that. There's our x, there's our positive 5. I'm going to use my other counter, my other tile, -1. Now here, I would love to be able to take away -1 from both sides, but actually I can't do that. So instead, I'm going to do something new. I'm going to add +1 to the left-hand side and +1 to the right-hand side. Now look at that. +1 and -1. Well, that's what we call a zero pair. It equals 0. It's like if I give you a cake and then take the cake away, you have no cakes. Or if I dig a hole and then fill in the hole, there is no hole. And that concept of zero pairs is very useful in working with negative numbers. So what am I left with? Well, I have x equals 6. Now, obviously, 6 minus 1 is 5. You kind of could have guessed it, but the principle is there. So let's try another one that's just a little bit more challenging. So x minus 307 is going to do exactly the same thing. We're going to add a +1 to create a zero pair there, and a +1 on the right hand side. I'm going to do that 3 times and create 3 zero pairs, and each time I'm adding positives to the right hand side. So just mark those as zero pairs. It's kind of a way of showing you're working out. And now, what am I left with? Well, I've got 3 lots of 0, which I can kind of ignore. And x equals, we'll add all of them together, x equals 10. 10 minus 3 is indeed 7. 2x minus 1 equals x minus 3. Can you guess what the first thing I'm going to do? First thing I'm going to do is take away an x from both sides. So we have x on only one side. And now there's 2 ways of doing this. I could add a zero pair. So let's add a +1 to make a zero pair. And then add a +1 over there and make a zero pair. And let's label those. And there's nothing wrong with doing that. But I want to show you a different way. Let me just undo that. And actually what I could do, rather than adding a +1, I could take away -1 from both sides. So take it away, and again I get x equals -2. So whether you want to add a +1 or take away a negative, you get the same answer. It's entirely up to you how you want to do that. 3x plus 1 equals x minus 9 is the sort of question that's going to confuse quite a number of my students, but Algebra Tiles helps us to make sense of it. First thing to do, we've got x on both sides. Let's remove x from the right and remove x from the left. I've got a +1, I can't take it away, so what I'm going to do, I'm going to create a negative pair, zero pair, by adding -1 to the left and adding -1 to the right. Let's just mark that as a zero pair so we remember that that represents 0. And then, just as before, we're going to have x, and we're going to split those between the two. We're going to divide them evenly. And then we're going to draw our ovals just to show what we have. It's a way of dividing by 2 in this case. And I can see that x equals -5. And I could check that one. 3 times -5 is -15, plus 1, -14. And -5 take away 9 is also -14. So again, Algebra Tiles helps us to deal with the complexity of algebra and also negative numbers. 7 minus x equals 5. For the first time we've got a negative x. How are we going to deal with that? Well, actually, we're going to do the same principle, but we're going to add a positive x. I'm going to drag my positive x onto my table. And you see what that makes? Well, first of all, let's draw one onto the right-hand side before I forget. But I have an x and a negative x, and that's essentially another zero pair. It becomes 0. All I have to do now is remove some of the constants. So I've got 5 on the one-hand side. Let's get rid of 5 counters. Let's remove them. Do the same to the left-hand side. Take 5 off. And what am I left with? Well, let's move it up. X equals 2. 7 minus 2 is 5. It's clear enough. But the concept, even those negative x, the principle still works. Now this one, I'm not going to complete, just to show you how incredibly complicated questions can be. We can still work with them. I've got some negative x's. I don't like negatives. Let's turn them into 0 pairs by adding x's to the left-hand side and then x's to the right-hand side. So there you go. We're going to have 4 x's on the right, and each of those become 0 pairs. So there's 0. So I'm left with 4 x's and a 7 equals -5. Well, I can't take away the plus 1, so what I'm going to do, I'm going to create some more 0 pairs by adding -1s. I need to add 7 -1s. So there they are on the right-hand side. And now I need to add 7 -1s onto the left-hand side. And once we're done there, you would be able to see that all of that is just 0. We have lots and lots of zeros there. What's left? Well, we have 4 x's and we have -12. Now, I haven't got space here, but you would break it out into 4 groups and you would end up with x equals -3. So even that complex, we can work with it. So here's some more for you to try. These are quite tricky. Have a go. I'll give the answers in a moment, so hit pause. And there's your answers. X equals -3, x is -1, x is 5, x is 0, and x is 4. The third one was quite hard. So we've learned to use algebra tiles, and I hope that you will continue practicing them until you become more confident with algebra manipulation. It really is an easy way to get your head around some of this more complex calculation. So far, so good. The problem is that in your exams, your teacher isn't going to be giving you some algebra tiles. We have to move towards doing this on paper. So I'm going to start solving this by adding x to both sides. So what does that give me? Well, on the left-hand side, I'm going to have 4x plus 1 and 9. So now, I want to get x by itself. There's a positive 1 there. Why don't we take away 1 from both sides? Gives me 4x equals 8. And then finally, I'd group it into 4 equal groups. And that's going to give me that x equals 2. So thank you very much for watching the video. I hope it was useful, and if necessary, do watch it again, because it does take a little bit of practice, but it genuinely is really very useful technique. If you haven't yet done so, please do hit like, and do consider becoming a subscriber to the channel. There are some other great videos on there as well. Thank you very much.